Hello, my friends. So today we are going to talk about linear relationships in grade 8. In grade 7, students learn about proportional relationships, and this is where they take the leap from proportional relationships to linear relationships, which is the foundation of all of algebra, but you guys got this. So proportional relationships, as you know, go through the origin and have a constant of proportionality. Linear relationships, on the other hand, have a constant rate of change, same, but they don't necessarily need to go through the origin. An example of that might be, let's say we're stacking cups. Every additional cup that you add to the stack increases the height of the stack, but that first cup has a lot more height to it than each additional cup will have after that. As students think about these different types of linear relationships, they start to notice a constant rate of change. So we can talk about the difference in the y values being constant every time you have the same constant difference in the x values. And they start to have different representations. So for example, let's say you have a scenario where an appliance repair guy shows up and he's going to charge you $100 for the first hour and then $50 an hour after that. So there's this added fee just for the house call. So from that scenario, they should be able to create a table, an equation, a graph, and from all of those representations, they should be able to go to any of the other representations. So from a table, I should be able to create a graph. From a graph, I should be able to create a table, and so on. They also learn that constant rate of change can be negative. So you can have the temperature decreasing at a constant rate of change, and that would give you a negative slope. And slope is also connected to the sides of similar triangles. So it's really about the ratio of the legs of those similar triangles. And so you can create these triangles, which, as you probably know, turn into rise over run as the way to remember how to create the slope equations. So in this example, if I wanted to know the length of those legs, I would have to subtract my y values and subtract my x values, and that's where the formula for the slope comes in. They also learn about zero slope versus no slope. So if I am thinking about the change in y, and I'm looking at this blue line, well, there is no change in y. So that would be 0, where the change of x could be anything, because